Okay. Share the screen now. Share screen. Let's share this one. Share screen audio. Start. Alright. Done with the share screen. Okay. Anything you want to ask me first before we start our lesson? So far we have 7 people here already. I only got si Ian punya paper lah. So today we go through Ian punya paper saja lah. Just to cut it short lah. Yeah. You can hear me, right?
Can, sir.
Yes, sir.
Huh? I can't hear you actually. Nah, bukan salah dia. Come back here again. Share video. Share screen with audio. Okay. So let me just repeat again. Can you hear me actually? I mean, are you able to hear me?
Yes, sir.
Yes, sir.
Okay. Some of you not so clear, but yeah. Let's see here. We start the class lah, since we have about 9 of you here already. We are actually doing number 2 actually. Yeah, if you look at the slide here on this page here, yeah, you have a circuit. Let me highlight the circuit first. You have a circuit containing a cell in the figure as shown. So you have the internal resistor, you have the resistor R1 and resistor R2, and you also given a EMF and a emitter. So if you really don't like this kind of a picture, it should be okay lah. So you have to focus on this one. Yeah, you better focus on the equation, because this one is the most important thing. In order to do question 2 better, it's better we do this. So we look at Ian paper here first. Ian paper is, who is number 1? Tu nah here. Okay. So this is your question. So the question say, make a expression for the gradient and the y-intercept. So what Ian do here is am I doing the same correct paper? Macam salah je paper ni. This one is 5-1.
Line to sir.
Lain ah. Macam mana ni we need somebody to send me the paper. Anybody sudah siap kah? Anybody from here already done question 2? Si Amin siap sudah? Insyirah?
Me.
Yeah,
tapi ada what? Yeah.
Can you send through the Telegram now?
Okay. Tapi ada one question belum siap, sir. Okay.
It's okay lah. At least ada something to write lah. Yeah. You send through the Telegram now. Yeah.
Okay.
Okay, everybody, we hold first. Well, I upload the file here. Yeah. Is the old one? This one? Okay. The Telegram. Where's the Telegram? What is the Telegram? As usual, I take a record of the session. So for those who are not here, you can have a look later on at the YouTube. Yeah. Telegram, yeah. Yeah. I'll wait for Inshira. Oh, Ian having dinner. Sorry. Block 1. Okay. Close. Oh, since we wait for Inshira to share the paper, just the tips lah from the YouTube just now. It's actually shared by Jigutio. So you can see there's a lot of method to do better in your exam. So please make use of the information from the YouTube. Yeah. Remember. Macam belum ada Inshira. Oh, you have to scan the paper lagi ya. Never mind lah. We do some of the question first lah. So let's come back here again. So this is not the question here. So maybe we do one here. Question 5.2. Is this the one? Oh, this one we already did. So come back here again. Block 3. Block 2. Yeah, maybe I can do here lah. Yeah. While we wait for Inshira, we just redo again the whole thing here. Yeah. This is from the question 1 actually. So let me rub it off so we can do it again. Okay. All right. Thank you for your patience. So we can just do again here. So for question number 2, you need to make the 1 over I against R1 plus R2. So this is the first task. So always remember this one is the x-axis. This one will be the y-axis. So you need to make 1 over I the subject. So what I do is you move the I to the other side. And then you should get the R1 plus R2 plus small r. And then the next step will be move the E to the other side. So you end up in R1 plus R2 plus R over E. So I can do some maths here. I can say that this one will be 1 over E bracket R1 plus R2 and then plus R over E. So it's the same thing. So this one will be my gradient. This one will be my y-intercept. This is y-axis. This is my y-axis. Y equal to mx plus c. So my gradient will be 1 over E lah. Correct me if I'm wrong. Yeah. So this one will be my y-intercept R over E. Inshira, kalau you sudah send, you let me know, Inshira. Alright. So we move on to the next one. We have the table, of course. So this table, we are given the uncertainty. Yeah. So this is the uncertainty is plus minus 5%. So each of these is plus minus 5%. So to get the R plus 1 is very easy. You just need to add it up lah. So 22 plus 33 is 55. And then this one will be 969. And then this one will be 78, I think. Yeah. 78 58, 60, 78. Yeah. This one will be 50, 80. This one will be 33 plus is 9, 9 plus 8, 89. And the last one is 3, 103. Yeah. So we have a plus minus for all the uncertainty. Okay. Now, how to get the uncertainty? Yeah. How to get the uncertainty? So this R1 plus R2 is actually come from uncertainty of R1 is actually you have to add the uncertainty of R1 plus the uncertainty of R2 because it's an addition. Yeah, it's an addition, so you don't need to do any multiplication. So you can just simply do 5% of 22 times 5% of 33, and then the answer you just simply add it up. Yeah. So let's have a quick calculator check here. So if you got a calculator with me, calculator with you, you can do a quick check lah. 22 times 0.05 is actually 1.1. Yeah, 1.1. 33 times 0.05% is actually 1.65. Yeah, 1.65. So if you add it up, it will become 2.75. Yeah, 2.75. So what should I leave my uncertainty be? You have to look at your table. So this is belong to the R. So I have to look at the R. So this is my R. If you look at the R, the smallest here is 1. Yeah. Insyirah, kalau sudah kau send, you let me know, Insyirah. So this is 61, 62, 63. So it's better we have a whole number. Yeah. Kalau for the uncertainty, we cannot know 1.7 ka 2.7 cannot. So we try not to use this. Instead, we make it into 3. Yeah, we make it into 3. 3 will be easier to plot. Yeah. Okay, there are many ways to do the uncertainty. If you don't like to do one by one, you can actually transfer the uncertainty to the last one, which is also 5%. So if you do 5% of 55, if you have a calculator with you, times 0.05, you will also get the same answer. It will be 2.75. Yeah. So that is how you do the uncertainty here. Okay. So I do a quick one lah. My last to do the calculation here. So we look at the answer here. So this is the answer. So this one will be, I also don't have the answer, so I need to calculate myself. So 69 times 0.05 is 3.45. So maybe just make it 3 lah. Yeah, it's a 3.45. So round off pun 3.4, 3.3 saja lah. 7.8 times 5%, you have 3.9. So this is a 4. And then 80 times 5%, this is a 4. And then the 89 times 5%, you will get 4.45. 4 is still a 4. Yeah. And then the last one is a 103 times 5%. You will get a 5.51. So it's a 5. Okay. So this is how you get the uncertainty done here. And this one on the other side here, you need to find the I. Alright, since most of you are here already, I think, yeah, 11 of you are here. So maybe I ask Amin. Amin, are you there, Amin? Oh, no response. See my mic. Is it the loudest? Yeah. Oops, take a picture pula. Amin, here,
Yes,
Amin.
Oh, yes.
Amin, how you get this? Have you tried already?
Yes, already.
Can you tell me how you get I?
Yang the last column ito.
Yes.
Okay. Our top column ito, it says 1 over I. We use the I from the previous column. For example, the previous column is 17.2. So we put 1 over 17.2, but we need to times by 10 power of negative 3.
Why?
Because the previous column milliampere.
Oh, okay. Thank you. You are correct. Yeah. So thank you again, Amin, for your clarification. So as you can see, you cannot just simply do 1 over 17.5, 1 over 14.2, 1 over 12.8 because of this, because of the power of 10, this one. So be careful. So whenever you do this, always check for power of 10. Check power of 10 to avoid the mark loss So we have a look at the answer here. I just quickly take down the answer over this side. So we have 58.1, 70.4, 70.1, 80.6, 87.7, and 99.0. Okay, so we can start plot the graph lah. But I need to wait for Inshira punya answer. So let me check the telegram sekejap.
Sir, share
Yes.
opinion na mo sen.
Huh? 6 sen?
Ah,
Oh,
tsaka wifi niya lambat.
okay. What about si Kashwi punya, boleh send Kashwi?
Boleh.
wonder-
Kalau pakai gambar saja sa boleh ka? Si PDF.
PDF kalau dapat.
Okay, sekejap pa.
Okay. Or whoever yang sudah ada convert PDF, anybody yang sudah convert to PDF kah?
Belum convert sir.
Anyone, si Asman kah, Bazli kah, the one here, Danish kah, Syaswani kah, Rosie kah, Sahibul kah, Sally, yeah. Just now also didn't remember to ask you to convert. So that we don't want to waste time here. So we wait for Kashfi to convert to PDF first lah. Yeah. So now, just to show you how we plot lah. So basically, I show you how I plot. So we have 55, 69. So be careful of the graph, because your graph is a bit small here. So this one is 55, yeah. This one is 55. So 55, and then it will meet with 58.1. 58.1. So this one is 56 bar, 56, 56, 57, 58, 59. So as you can see, kalau 0.1, we actually cannot do a 0.1. We can only choose 58, yeah. So 58 will be the best choice lah, yeah. So this one we have to choose 55 and 58. And the error bar just now is 3, so it's a 1, 2, 3. So this will be the error bar, 1, 2, 3. So we have an error bar like this, yeah. And then we have another one is 69. Here we are. This is 69 here. And then we have 70.4. Now 70.4, 70.4 is actually doable, yeah, because 71, 72, 73, and then this one is 74. So 70.4, you actually can get 70.5. So doable actually, yeah. So 70.5 will be here then, yeah. And then I remember the error bar is 3 box also. So we can have 1, 2, 3, 3 box. 1, 2, 3, 3 box. So it will be like this, yeah. And then we carry on with the 78. So 78 is somewhere here. This is the 78 range. We have 78 when wow, 78, 78. Oh, nice number, 7878. So this is 76, 77, 78. This one is 78. So 78, 68 will be here. And I'm not mistaken, just now the error bar 78 is 4 already, so you can use 4 here for 78. So it'll be 1, 2, 3, 4, and then the other side will be 1, 2, 3, 4. So now we have the error bar becoming bigger and bigger lah. Okay, and so on and so on. I think if you plot also, this one should be doable lah. Yeah. So this one should be doable. And then of course, once you finish the plot, let me plot the last one. So 103 is here. Okay, I should make a tanda lah, so that I know it's 1 over 103. 99, so 99, this is 100, so this one is 100 bar here. So 103, 99 will be here, 99, and it's a 5, so 1, 2, 3, 4, 5, and then this one also 1, 2, 3, 4, 5. So it's a very long error bar. All right, so once you have all this error bar here, you of course you try to plot lah, you try to get a straight line like this. Oh, okay, never mind, salah already. Erase it again. So let me just draw a better straight line. So you have something look like this. Also, never mind lah, okay, I try my best again. I'm not so good in drawing. Don't have any ruler with me here. All right. So this is the kind of the best fit line lah. So you always label it as the best fit line. Now, the most important for this graph, yeah, the most important for this graph is the worst fit line, yeah. Worst fit line, they are, worst fit line, there are many ways to do, yeah. One, you use the extreme, yeah. You have to use the extreme end here and the extreme end here, and then you can draw a straight line from here to here. Yeah, this one will be one of the worst fit line. Or you can choose the other extreme. Yeah, this is what we call the extreme lah. So meaning that you can draw from here to here. Yeah, that will be the extreme. So either one will be doable lah. So you just choose one lah. Okay, you choose either one. Either one. Kashfi, siap sudah Kashfi? Belum?
Sudah sir. Tadi dah.
Okay, thank you.
Ada
So we can
si Insyirah punya.
Okay, thank you. So we come back here. Insyirah and Kashfi. So I download both lah. Can I actually do with the Cola notes? Oh, can. Yeah. So you do the Cola notes paper 2, yeah. So we have save it here. This one is Kashfi punya. This one is Kashfi punya bah, ataupun Insyirah punya. Whose one is this?
Aku punya sir.
Okay. Alright. So you do the correction teruslah tuan ya. I assume you do the correction on the spot ya, because I can see you change your value here. Am I right?
Lurus sir.
Okay. So now we teruskan sajalah. So we have the scalping saja ni hendak. Different a bit. I cannot zoom in, zoom out. Yeah, never mind. So normally you will choose the best fit line, the point, and then you get the gradient, and then you have the worst fit line, and then you get the gradient, and then after that you should get the uncertainty. Macam mana you dapat the uncertainty? I don't see you get the uncertainty. How you get this? How you get this 0.1? I don't see any working here.
Tu sir yang steering gradient best fit line ko.
Steering gradient best fit line. Oh, terus. Okay. I see that here. Yeah. So I think it's better you do alih-alih lah. You make a macam uncertainty gradient equal to modulus of gradient best fit line minus the uncertainty. Salah. Sorry. Gradient is the gradient for the best fit line minus the gradient for the worst fit line. Modulus, yeah. So you get rid of the minus sign. Okay. Now, let's say your gradient, selalunya we don't penalize the selalunya we don't penalize the gradient lah. Okay, selalunya we don't penalize, because kalau penalize pun from your graph we already penalize here. Yeah, what I mean is, if you did not reach the there is a condition. Let me show you here. There is a condition. Let me just check for you lah. Okay, so the condition is here, 65, 61, 65. So this is 61, and then 65 is here. So you must have 61, 65, and then 63.5, 63.5, and then 65. Okay, so this one is within the range. And then we have a look at the other side. We will have 96.5. Who is 96.5? This is, sorry, I need to make a 96 will be somewhere here. 96.5, 95. So 96.5 is here, and then 98.5. 98.5 is here. So this is also within the range. So you will not be penalized lah. This is your best fit line. Best out of the best sudah tu. Yeah. Then the worst fit line, make sure that it pass through the error bar. All this they must touch the error bar. Semua mesti touch the error bar. Okay. So I make a note there. Best fit line and the worst fit line, make a note there. Must touch the error bar. No matter what, they must touch the error bar, or else you'll be in trouble. You'll be penalized. Okay, so we go back to the front page, and then we do the same thing also for the y-intercept. Yeah, so the y-intercept, you use the y equal to mx plus c. Yeah, you get the y-intercept for the best fit line, worst fit line. Kashfi, you will get penalized nih, Kashfi. You know why you get penalized? Because you didn't mention which one is the best fit line punya y-intercept, which one is the worst fit line punya y-intercept. So you have to label this one is for the best fit line, and then this one is for the worst fit line. Yeah. So pastikan you mention this in the exam. Okay. Must indicate. Yeah. You must indicate. If you don't indicate, they will have a chance to penalize you. Yeah. So we don't want to give the marker chance. Yeah. As you can see Kashfi punya answer is a bit very big. You see the uncertainty is 20. Yeah. But the y-intercept is only 12.3. No worry. Yeah. No worry about this one. Because just now I marked the other paper from block 3. They also have similar answer also. Never mind. We look at Inshira punya y-intercept. So let's have a look. So we have Inshira punya paper. This is Inshira one. Straight away, color notes. Yeah, done. Loaded. So Inshira one, have a look first. We have a look at Inshira punya paper. So if I do like that, it doesn't want to. If I direct, it don't want to let me slide. Yeah, it's okay. Alright, so as you can see, Inshira punya paper is a bit weird lagi ya. This one is 10.19. Tu lah, dia ada label. So you must label the worst fit line, which one is the best fit line. So this one you use the y-intercept, the coordinate, then you get 10.13. The other one very funny, you see. She actually got a minus 1.2. So what happened is the uncertainty will be, remember you have to deduct them. Yeah. So remember y-intercept uncertainty, y-intercept is the modulus y-intercept for the best fit line minus the y-intercept for the worst fit line. So for this case, it should be 10.19 minus, because this is a minus, so it has to become minus 1.12 modulus. That's why she had this 11.3. So it's alright ni. Insyirah, nada salah tu. You write down this one, you also got the full mark. Yeah. Cause adangnya ada sometimes there's a slight error lah. Okay, there's a slight error. And then we go through the next one, the part D. So part D, you need to use the answer from A. A is the expression, yang the one you get this one. This is from A. This one is from A. This is from your A. Okay, and then your B, your part C is where you get your gradient. Okay, and then your part C4 is where you get the y-intercept. This is all the information you need. So from your expression, you can get your E by simply getting the gradient. So you get the E equal to 1.14. Okay, so this is correct. Sorry, this is correct. And then you got the other one is the y-intercept. It's the R over E. So I better don't write this one. Yeah. So you can see the R. So it's a R over E. So you use the E from your previous answer here. Pindah ke sini, you should get the R. Right? Now, the unit. The unit I need to comment a bit. This one is actually wrong. Yeah, it's volt. Yeah, this is ohm. So get a -1 here only. Yeah. Now, how do I know the unit? Yeah. How do I know the unit? This one. Now, one easy way is, rather than you finding the finding the unit from graph, okay, you can actually you can read the front page. Yeah, read the front page for information. Yeah, let's say what kind of information in the front page. Let me share with you here. Easier I slide into this one. So let's see here. So if you can see from the statement, right, your E is actually the EMF. Yeah, so EMF actually is volt. Yeah, and then as you can see, this is your small r, is a resistance. So resistance will be ohm. So this is how you get the unit without doing all those calculation from your graph. Yeah, this is how you go the calculation from the graph. All right, then the last one here, for your information, this one, the last question, I write some tips for everyone. Use the original expression. Okay, original expression from page 1. Yeah, from page 1. So this one is the original expression you get from page 1. So you just need to substitute the E that you get from earlier on. This one is given. This one is given from the I here. And then also this is also given. Yeah, this is also given here. And the R also you also calculated on your own already. So all you need to do is do some algebra to solve for the value of R2. Okay. Since this are uncertainty not yet answer, we have look at the Kashfi punya dulu. We look at Kashfi punya answer. Ada si Kashfi jawab.
So uncertainty ku yang y-intercept salah banyak.
Y-intercept salah. Pasal?
Cenaka boleh jadi 20.
Oh yeah, I didn't check also. So it's a modulus uncertainty y-intercept will be modulus 12.3 minus 19.44. So 12.3 ada apa? I count, you also kira also
7.14.
7.14. So you can make it 7.1 lah. 7.1. Alright. So kalau kau buat salah-salah, that means sini pun salah lah tu. Part 2. Okay, this is your part 2. Let me just scroll down to the question. Uncertainty of E. So this is your uncertainty of E. I try to rewrite what you write. So maybe I write down somewhere here lah. Somewhere sini lah. Okay, so it was given in the front. It was given in part 1. Your gradient is equal to 1 over E. So you want to make uncertainty E, you have to get the E, the subject first. So it'll be 1 over gradient. So you do the basic step. No? Uncertainty of E is uncertainty of E over E is equal to uncertainty of gradient over gradient. And last but not the least, tu nah sini. This E pindah the other side become time E. So this is what the Kashfi is trying to show us. Yeah. So let me write down here. This is what Kashfi is trying to do here. So he got the answer kind of very small. 0.1. Let me check. 0.1 dari mana ni? 0.1 from your gradient. Let me see your gradient. Okay. Your gradient tu 0 atau 0.1 and then you have your gradient which is 0.52 times 1.17. 1.17 is the answer from your previous answer. And also Kashfi, kau punya unit kau nak buat sini This is a V, this one is the O.
So ketinggalan unit.
Oh. So this one might be a -1 here lah. Or deduct mark here. Alright, so overall, if I look at your paper, there's nothing much wrong here, except for this one got a -1, and then this one they might deduct mark for you. I just deduct here lah, deduct here. This one no problem because if you look at the mark scheme just now, let me just double check lah the mark scheme here. So if the rest you have done your part, you can have a look at the mark scheme also. Yeah, can also lah. Yeah, dari 5.12 also can to 2.75. Not deduct mark for this one. So overall,
Sir,
yes, Amin.
Kalau uncertainty tu kan, how to find yang best fit line minus worst fit line kah?
Uncertainty for what first?
Gradient.
Uncertainty for gradient. You mean this one, right? Ani kan, you mean? Ani kan? Uncertainty for gradient kan? So
yes.
What were you saying again? I mean,
best fit line minus worst fit line ataupun terbalik. Worst fit line minus best fit line.
Okay. Amin was saying, should it be gradient best fit line minus gradient worst fit line, or gradient worst fit line minus gradient best fit line? So which one should it be? Now to saja Amin, to clear the confusion, okay, we use modulus saja Amin. So you have a gradient uncertainty for the gradient kan, modulus saja Amin. Modulus, so bila kau simpan modulus satu, walaupun ia punya answer is minus, it will become positive also. So don't worry, you just add a modulus between them saja, kan? So for example, Ani, for example, Ani tolak Ani, you have a negative, you have a positive value, so it's alright lah. Tapi bila kau pakai best fit line tolak with the worst fit line, you have a negative value. But because of the modulus here, so you will get rid of the minus sign lah. Boleh faham tu Amin?
Okay. Same konsep untuk y-intercept lah tu sir.
Yes, correct. Y-intercept pun sama. So you have to
Okay.
use this one. Modulus, try to use modulus to clear the doubt. Macam which one minus which one, so you make a modulus, then it will be fine. Yeah. Alright, so I just go through with you again, everybody here lah. So to clear the doubt lah, one by one, then we are off for today lah. Sally, we start with Sally from the bottom. Yeah. Are you here, Sally?
Yes.
So any question you want to ask about this question 2?
So far I'm okay, je.
Alright, alright.
Yeah.
Thank you. Sahibul?
Nada sir.
Ada. Oh, clear. Tekniknya
Nada.
semua ingat.
Clear sir. Okay.
Alright, next one we have. Thank you, Sahibul. Rosiana.
Okay.
Rosiana ada.
Mata sir yang pasal
Nada.
absolute uncertainty yang ada table tu sir.
Ya. Oh, nada dengar. I can't hear you, Rosiana. Ya, kadang-kadang this internet punya source lagging. Maybe you type at the Telegram. I have a look sekarang sebelum I call off for today Nada dengar.
Itu sir.
Rosie, I cannot hear. Ya.
Yang pasal absolute uncertainty yang ada table ni kan. Better we refer to the graph given kan sir.
It's up to you pulang, Rosiana. Just mestinya ia mesti refer to the graph given. Pasalnya sudah kau draw arah graph itu, this one memang payah draw ni. This is hard to draw. Hard to draw the error bar. Hard to draw. Because 2.8 arah graph itu payah bah. 3.9, 4.5 boleh lah. Tapi kalau 2.8 memang a bit susah sih. Kalau 2.8 macam mana ni? Macam kalau Inshira punya, ia pakai 1, 2, 3 sudah. Ia pakai 30. And then this one, ia pakai 1, 2, 3, 4. Kenapa pakai 3, 4 lah? Oh, ia pakai 3.5. Okay. I think Inshira you to minus 1 this one. Kau punya value you need to minus 1. Pasalnya, saya ingat just now is 3.4 bah. Yeah, 3.4 something. So maybe, boleh je lah. I think can lah. Sekejap I look at the scheme sekejap. 2.8. Nada yang specified. So should be fine boleh lah. Yeah. Rosiana, just semestinya semestinya follow the table lah. Tapi bila kau plot error bar tu, pandai-pandai tau kau pandai-pandai tau kau macam fix the range lah. Because you cannot plot 3.9 or 2.8 on the graph. Hope that help you to clarify your doubt. Alright, next one we have, yes. Ada lagi Rosiana?
Nada sir.
Okay. Syazwani?
Nada sir.
Okay, thank you. This one is Danish today. I can only see MU here. Is that Danish? Danish J? Yeah. Okay, another respond. Next one. Maybe this one is... Amin ada sudah. Who is this? Never mind. Ian?
Sir.
Yes.
Kalau certainty yang ada table itu salah, sir, semua salah sir yang di belakang.
You mean kalau this one?
Yes.
Alright. Kalau sini salah, okay. If wrong here, you will be only penalized once. You'll be penalized once saja. So meaningnya, you use the value yang salah ni, you plot on the graph, and then you get your y-intercept gradient apa, you'll be not penalized lah. Okay, you'll be not penalized. But I have to remind you, kalau ni salah, okay, if this is wrong already, when you plot it on the graph, your graph will look very weird, yeah, it will look very weird, and then the error bar will be somehow too short or too long. If you find that the error bar is too short or too long, that means your error bar here, the uncertainty yang you find out here, it could be wrong, yeah, it could be wrong, because normally if you have a error bar, the error bar should be nicely, nicely spaced so that you can draw the best fit line and the worst fit line. So example, just now what Ian say, kalau salah, if your value here is all wrong, if your value here is all wrong, and then you plotted it, you might get deducted for the penalized here, but your best fit, your gradient and your y-intercept might get the wrong technique, yeah. Sometimes you cannot draw, so which will lead you to penalized mark further on lah. So double check sajalah. Kalau your error bar you draw lawak, okay lah, carry on sajalah. Kalau error bar yang macam dah berapa smooth, you better double check again, Alright, let me check who is this. Curious also. Kashfi and Danish. Okay. Kashfi?
Nada sir, okay.
Okay. So Danish, another response. So
Nada sir.
Another. Okay. Danish K.
Sorry sir.
Nada sir.
Nada. Bazli?
Nada sir.
Okay. So Asman?
Aku okay sir. Lepas yang Amin tanya yang uncertainty tadi.
Okay. And the last one is Amin. Yeah.
Kalau macam ada question D sir, yang part D.
Question D, wait Yeah.
Part D sama E kan. Final answer give to how many significant figure ataupun decimal place.
Oh, you are
on judgment kah?
Okay. Your answer for this and this, I recommend 3 significant figure. Yeah.
Okay.
Because paper 5 ni Ian dah very strict about the answer punya sig. It could be 2, it could be 3. So we make it 3 lah. Okay. We make it 3 sig lah. Just to be safe lah. Just to be safe. Yeah. Alright. So if
okay, sir.
Alright. Thank you, Amin, for your question, and thank you everybody for your time. Yeah. I know this coming Thursday there will be paper 5 in the afternoon. So make sure that you know how to. The most important thing is this part lah. Yeah, y-intercept and also the gradient and also this part. The other one here, if you find it very hard to digest, try your luck saja lah. But jangan salah sini all those, the y-intercept here, all the E and R here, yeah. Try not to lose mark lah, yeah. And also part 1 here is the algebra. Let me show you here. This one is sometimes is quite challenging, yeah. Sometimes is quite a challenge to answer because sometimes it involve log and exponential. Yeah, if it's involve log and exponential, then you need to apply your maths lah. For your info, this coming Thursday, I remember there is no exponential and logarithm, just simple arithmetic only. Yeah. So wish you all the best. Make sure that you do your algebra properly. Jangan terbalik. I can see sometime A equal to B over C. You make C the subject. Terbalik. This one become A over B. This is wrong. So please make sure that your algebra is make sure your algebra is very good. Jangan cuai ya, especially those yang over ni. Jangan cuai ya. Yeah. Alright, if there's no other question, we will stop early today lah. Thank you and sorry for the time. I need to take this afternoon. This afternoon you got your maths, so I need to finish off this one. So tomorrow we do another paper. No. Tomorrow I just have a review for as many papers as I can sajalah. Alright. So if no more question, you can go now. And good night. Yeah.
Thank you, sir.
Thank you, teacher.
Thank you, sir.
Alright.
Thank you, sir.
Bye.
Okay, thank you, sir.
Thank you, sir.
Good night, sir.
Good night.